Alright, in this video we're going to find out how to form a matrix of cofactors of a 3x3 matrix, and this is something that we'll need to do if we ever want to find the inverse of a matrix. So let's have a look at it. The rules on how to do this, they're quite simple as long as you follow them. For each element in turn you find the minor 2x2 matrix determinant. So you take each element and then you ignore the other elements on the same row and same column, and then you multiply the diagonals and subtract them, the same as when we found a determinant of a 2x2 or a 3x3 matrix. What we do next is write the answers in another matrix. So for a 3x3 we're going to end up with 9 cofactors. Then every other cofactor has to have its sign changed. So if it turns out as plus, we need to make it negative, and if it turns out negative, we need to make it plus. And then you'll end up with a matrix of cofactors. So let's have a look. Here we've got a 3x3 matrix called A. So in turn we take all of the 9 elements and then ignore the row and column, the other elements on its row and column, and multiply the other diagonals. So for 5 we're going to be multiplying 6 3's, take away 2 4's. So let's have a look at that. So it's going to be 6 times 3 take away 2 times 4 is 18, take away 8, which is 10. So that was simple enough. And then for element 2 we ignore its row and its column and we multiply the diagonals of what's left, which is going to be 5 times 3 take away 4 times 4, which will be 15 minus 16, which is minus 1. So it would have been minus 1, but remember every other element we need to change the sign of it. So we need to change it from minus 1 to plus 1. And now we're on to element 1. So we ignore the numbers in its row and column, and we'll be multiplying 5 2's by 4 6's, which is 10 minus 24 gives us minus 14. So we've done a top row. Now we're going to start here. So the cofactor of the fourth element, so the second row first column, this 5, we forget the row and the column. It'll be 2 3's minus 2 1's, which is 6 minus 2, which is 4. But because it's every other one, so it's the second and the fourth, 6th, 8th, etc. for a 3x3, the second and the fourth cofactors need to be inverted, have their sign changed. So it was 4, we make it minus 4. Now for element 6, the cofactor, we ignore 6's row and column, so it'll be 5 times 3 take away 4 times 1, which is 15 take away 4, which is 11. So that's that. And now we're on to this element, second row third column, which is 4. So we ignore that row and that column and we multiply everything else. So it's going to be 5 times 2 take away 4 times 2, which comes out as positive 2, but because it's every other one, so the second, the fourth and the 6th and the 8th, the 6th position, we need to change the sign from 2 to minus 2. And now we're on to this element 4. This one's a bit easier because it's in the corner. So we're going to multiply 2 4's minus 6 times 1, which end up as 2. Last but 1 is this element here, so we ignore its row and column and multiply everything else. It's going to be 5 times 4 minus 5 times 1, which comes out as 15, but because it's every other one, 2 4 6 8, this will need to have its sign change from plus 15 to minus 15. And finally we take this element, third row third column, which is a 3. We ignore the column, ignore the row and multiply everything else. It's going to be 5 6's take away 5 2's, which is 30 take away 10, which is just 20. So we've already dealt with changing the sign of every other element. The first one we don't need to change the sign, but it's every other one starting with the second we change the sign of. So you write down 10, 1, minus 14, minus 4, 11, minus 2, 2, minus 15 and 20, and you put them into a 3 by 3 matrix, and that is called the matrix of cofactors. So we took every element in turn, we found the little minor 2 by 2 determinant, wrote them in a matrix, and we changed the sign of every other one starting with the second. And that's how you do them. Pretty simple as long as you follow the rules. So if you've got any questions on it, feel free to comment, and thanks for watching.